Hello, this is Dr. Christy Patton-Lokes, a chemical engineering professor at Missouri S&T. We are continuing to look at estimating manufacturing costs based on Chapter 8 of Turton et al.'s textbook for process design. And in this lesson, we will be looking at raw material cost estimation. Now, from the beginning of the chapter, what we found is that the formulas for cost of manufacturing could be based on depreciation or no depreciation, but they involve fixed capital investment, cost of operating labor, cost of waste treatment, cost of utilities, and cost of raw materials. We have in previous lessons looked at all of these other items. This is our final item to consider. Now, raw material costs are probably the worst thing to estimate. Usually, to get a realistic value, you really need to talk to a vendor. But if you're doing this for a course, do not bother a vendor by calling them up and asking, if I needed to buy 1,000 kilograms per day from you, how much would you charge me? They don't want to waste their time on that, okay? There is a table in your book that can be useful. It is based on $2001. Unfortunately, most chemical prices are much more volatile than a really simple extrapolation to the future using SEPSI would make you guess. You also can look at some online resources. Alibaba is probably the most useful in general for getting a sense of what prices are relative to each other for various sizes of shipping. Now, that's the other issue, is these things are going to depend on how they arrive to you, okay? So are you buying them railroad tank cars? Are you going to order and get one railroad tank car per day? Or do you need one railroad tank car for 6 months? Okay, that's going to kind of be a difference in what you're doing. You may be doing it by barge along the Gulf Coast, they're saying here. Various ways that they can get you the materials. And frankly, the shipping really changes the cost. If you are taking a design class with me, we will early in the semester agree to prices of raw materials and products. And they may or may not be realistic, but we will come up with some numbers. Let me just show you, since the examples in Turton's textbook are based on this using toluene to produce benzene process, look at these graphs. These are actual graphs that I found online of prices for benzene, this blue here. Okay, and look how much that changes. This is just over a 3-year period, and how dramatically it's changed from $850 at the low to a high of $1,500. Okay, this red graph here is the price of toluene. Now, sometimes it's been very cheap, okay? Sometimes it's been very, very expensive. If you have a process that's profitability is all going to be based on what the cost is, and you design it for when your raw material is at a very low price and your product is at a very high price, and then by the time you've finished your design and built the plant, you now have your raw material at a very high price, your profitability just went down the tubes, right? So fluctuations in prices is going to matter a lot. We call that volatility. Now, another issue with estimating your raw material costs is that you are unlikely to operate your plant 24/7, 365 and a quarter days of the year. You probably are going to have some shutdowns. Now, some plants will, in fact, maybe go for 2 years without a shutdown, okay? But others are going to have shutdowns all the time. typically what you can expect is that the plant will operate 90 to 95, 96% of the time. Okay? So you need raw materials for that 90 to 96% of the time. They're going to call that the stream factor, okay? Which is going to be a percentage of the days that you actually are using your raw materials. Now, we're not going to apply the stream factor to things like our electricity costs and so forth, because frequently on those shutdown days, we may still be operating some of that equipment for testing, or it's during the startup phase or something like that. But for raw materials and for product, the stream factor is going to be very useful to us. So let's look at this example. A chemical plant uses 10 metric tons per hour of toluene in order to produce 8.2 metric tons per hour of benzene. We're going to operate the plant with a stream factor of 0.95, or we'll run it 95% of the time. And if we use data from January of 2014 from those graphs I just showed you, the price of toluene was $1,140 per metric ton, and the price of benzene was $1,360 per metric ton. Now the first question is, what's the price of my raw material each year? So my raw material is the toluene, okay? So for the toluene, I have 10, I'm going to use MT for metric tons per hour, and $1,140 per metric ton gets me dollars per hour. I'm going to run this 365 days per year times that stream factor of 0.95. Okay? That's days. I've got hours, so I need 24 hours per day. Okay? And therefore, this is going to cost me $94,870,800 for my toluene each year. Okay, that's a lot of money, but hopefully we'll make it up by producing all this awesome benzene. Okay, so typically what they really ask you to do at an early stage in your design is estimate a cost margin. Okay, so you want to know the margin. And what this means is how much more valuable is my product than my raw material. And in this case, we're asked to do it per kilogram of benzene. So we're going to take the annual money I can make from selling benzene, subtract off the material I paid for, my raw material, toluene, and then divide that by the mass of benzene. And we can do this annually, or actually I did it per hour. So therefore, I'm going to take 8.2 metric tons of benzene. The price of benzene is $13.60. Subtract off 10 metric tons of toluene. The price of toluene is $11.40. I'm going to divide that by the mass of my benzene. So this is going to be dollars per hour over metric tons per hour. And so I end up with negative $240 over 8.2 hours, negative $30.24 per metric ton of benzene. Okay, here's the sad fact. That's a negative number. Okay, that means that I am going to lose $240 per hour, okay, on this material. Or negative $30 per metric ton of benzene produced. This is not a profitable project. Based on these prices, I should not continue the design. Do you see how important it is to be able to do a profit calculation like this early in the design phase so that you know whether or not to continue? So clearly they do make benzene profitably. This must not be the way, or the cost information that I have is maybe not so necessarily realistic. But this is the sort of calculation that's fairly easy. It's going to be important in estimating profitability in coming chapters, and it's a quick calculation. So in the next chapter, we are going to look a little bit closer at the time value of money so that we can then study profitability estimates. Thank you very much for your time.